Hi guys, welcome to my YouTube channel Physics Prince. My name is Deepak. I'm going to teach you all 9 subjects of physical science in detail. My courses are going to help the students who are preparing for CSIR, NET, GATE, NT exam, PhD exam, SET exam, Jest, TIFR, IIT-Jam, and other exams related to physical science. Okay, so also I would request the students who haven't subscribed my channel yet, please subscribe my channel and watch my free live classes which are going to help you to crack the examinations related to physical science. Okay, so today it's a Sunday special class, and in which I'm going to discuss first part of the optics, in which I will discuss interference of light in detail, right? And I will solve all the questions related to it which were asked in different examinations related to physical science. Okay, so we will study interference of light in detail. So this is the first part of the optics. Okay, in second part of the optics we will study polarization of light in detail. In third part of the optics we are going to discuss diffraction of light in detail, and in fourth part of optics uh, we will solve all the questions which were asked in national level exams. Okay, so I'm going to complete optics in 4 lectures. Okay, so this is the first part of the lecture, and in which I'm going to discuss in detail uh, the interference of light. Okay, so I'm going to start. This is the optics part first. Okay, okay, so first will so so we are studying optics, means studying light. Okay, light. Meanwhile, just let me check whether I am audible or not. That is very important, because many times there is issue with audio. So study, yeah, I'm audible. Okay, so light, rectilinear propagation of light. Okay, so there are some properties of light. Okay, so which I'm going to discuss. Rectilinear propagation of light. Rect, rectilinear propagation of light. Some properties of light I'm going to write. So this is rectilinear propagation of light. Okay, similarly there is reflection, okay, of light. There is uh, refraction, refraction. There is dispersion. These properties are shown by light. Okay, dispersion, interference, okay, uh, diffraction, diffraction of light. Okay, and polarization, polarization polarization of light, okay, and then scattering. These properties are shown by light, okay. Okay, so so I'll just give brief idea and then we'll proceed further, okay. So here that there are different theories which is given about light, right? The first theory was given, that is particle theory, okay. particle theory Particle theory, just brief idea I'm giving, okay. Particle theory, that is uh, Newton's corpuscular theory, okay. That is Newton has given first the theory, okay. Newton's corpuscular Newton's cor corpuscular theory, okay. That is Newton's corpuscular theory, that is particle theory, which is given by Newton, okay. And that is light travels light light travels in the form of in the form of stream of particle, in the form of stream of the particle, okay. Light travels in the form of stream of particle, okay. So light is stream of particles, okay. So that is what said in Newton's corpuscular theory, okay. Second is that for light the wave theory is given, okay. So that is wave theory, just giving you brief idea, and then we'll discuss interference, okay. Because for your exam purpose, interference is very important. You'll get questions of 5 marks or 3.5 marks in NET and other exams, okay. Yeah, so wave theory, that is the Huygens gave this theory, okay, or we can say Huygens Huygens uh, wave theory, okay, which we have already studied in class 11th and 12th, okay. Just a brief idea on Huygens wave theory, okay. So what Huygens said, every light source every light source every light source produces some disturbance every light source produces some disturbance in the surrounding in the surrounding, which propagates which propagates at the speed of light, okay. At the speed of light, okay. So that's what said in Huygens wave theory, okay. And they have explained the wave nature of light, okay. Now Maxwell's electromagnetic theory, for the light, Maxwell also given the electromagnetic theory, right? That is Maxwell's electromagnetic theory, electromagnetic theory. Okay, Maxwell's electromagnetic theory. So Maxwell uh, given electromagnetic theory, right, for the light energy. Okay, so light energy is a this is light energy. Light energy is a wave which is which is electromagnetic in nature, which is electromagnetic in nature, electromagnetic in nature, in which in which electric field E and magnetic field V. Okay, in which electric field vector. Okay, electric field vector or electric field E and magnetic field V oscillating 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 in perpendicular planes perpendicular planes to the direction of to the to the direction of propagation of propagation of light. Okay, so light energy is a wave which is electromagnetic in nature, and in which electric field and magnetic field oscillates in perpendicular planes to the direction of propagation of light. Okay, and he has given formula, that is E equal to E equal to vector E equal to vector Vc. Okay, C is the speed of light. Okay, that's what it is given. So that is light is electromagnetic wave, right? And electric field and vector field are mutually perpendicular to the direction of motion of the motion of the light. Okay, that's what Maxwell said. Okay, so just a brief idea. Okay, so now we are studying interference of light. So this is about the light, right? These are the properties which light has shown. Okay, and these are the different theories which are given for light. Okay, so now interference of light. Okay, interference interference of light interference of light interference of light. Okay, so what is this? What is the definition we are going to write? Okay, the definition is when two coherent waves when two coherent wave when two coherent waves superpose at a point superpose at a point, then the resultant intensity the resultant resultant intensity resultant intensity at that point is different from the sum of two individual intensities. Okay, intensities. Okay, so this is the definition. Okay, so when two coherent waves superpose at a point, then the resultant intensity at that point is different from the sum of two individual intensities. Okay, so like this is these are the sources. Okay, this is S1 and this is S2, and this is the wave, light wave, and this is this wave. Okay, and they superpose at here. Okay, right at point P. Okay, so now I'll tell you what is coherent waves. Okay, coherent waves coherent waves coherent waves for coherent waves, what should be the condition? There should be same phase coherent waves means the same phase. Okay, point 2 is no time lag. Okay, if two waves are coherent, then they would be in same phase. Okay, and no time lag, there shouldn't be any time lag, no time lag. Okay, third is constant frequency. Okay, so this should be constant frequency constant frequency and number 4 constant frequency, and number 4 is constant initial phase difference. Okay, constant initial phase difference So if two waves are called coherent if they have constant initial phase difference. Okay, the phase difference should be constant. Okay, and there should be constant frequency, there shouldn't be any time lag, or they should be in the same phase. Okay, then the two waves are called coherent waves. Okay, now we'll give mathematical description. So let y equal to a1 sine omega t. This is the wave equation for first wave. Okay, sine omega t, that is y1. Okay, and y2 is a2 sine omega t minus 5. Okay, these are two waves, y1 a1 sine omega t and y2 a2 sine omega t minus 5. Okay, so resultant is going to be y, that is y1 plus y2. Okay, we'll add it. So this is going to be y equal to a1. These are also a1. Yeah, that's correct. A1 sine omega t plus a2 sine omega t minus 5. Okay, so this is going to be a1 sine omega t plus a2 sine A minus B, right? We know sine A minus B is sine A cos B cos A sine B, right? So this is going to be A1 sine omega t, A2 will take common, so this is A2 sine omega t cos phi sine A sine B minus cos A sine B, right? So minus cos omega t sine phi, right? This is the one. Now we'll multiply, so this is going to be A1 sine omega t plus A2 sine omega t, okay, cos phi minus A2 cos omega t sine phi, right? So this is going to be, take it, this is going to be A1 plus A2 cos phi, we take common, so this is going to be sine omega t minus A2 sine phi will be common, this is cos omega t, okay. So let this term we can say r cos theta, right, and this term we say r sin theta, okay. R sin theta, so y resultant y is going to be, we'll write r cos theta sin omega t, okay, y is going to be r cos theta sin omega t minus r sin theta cos omega t, right? Again this is cos A cos B, right, minus sin A sin B form, okay. Cos A sin B minus sin A cos B form. So this is going to be, y is going to be equal to, this is r sin omega t minus phi. If you open this sin A minus B, right, this is going to give this value, okay, this one. So this is the resultant, okay. Now where r is resultant amplitude after superposition, okay, r is resultant, resultant amplitude after the superposition, superposition of light, okay. And since we know r cos theta is, we know that is a1 plus a2 cos phi, right, this one we say this term is r cos theta, right. Similarly, now we are going to find value of this equation 1, okay. And r sin theta is this one, r a2 sin phi, right. Now we'll find the value of r. So what we'll do, we'll square and add equation 1 and 2, okay, squaring 1 and 2 and adding. So this is going to be r square sin cos square theta plus r square sin theta. R square will take common, that is cos square sin theta plus sin square cos square theta plus sin square theta is, value is 1. So this is going to be r square, right. R square is going to be this one, a1 plus a2, after squaring and adding it is a2 cos phi, okay. So this one I'll write it, that will be better for understanding, okay. So this is going to be r square cos square theta plus sin square theta, okay, is going to be a1 plus a2 cos phi whole square plus a2 square sin square phi, right? This one. So value of this value is 1, right? Cos square theta plus sin square theta is 1, and so r square is going to be root, my apology, so this is going to be, we'll open this, okay, a plus b whole square, right? And cos square and plus sin square theta is going to be 1, so this is going to be value, this value is going to be a1 square plus a2 square plus 2a1 a2 cos phi, okay, a1 square plus a2 square 2a1 a2 cos phi, okay. Then value of r is going to be root a1 square plus a2 square plus 2 a1 a2 cos phi, okay. This is the value of r, resultant r, value of r, okay. Next point, and r we have found out, right? This is the r, and similarly we will find theta, okay. So tan theta is going to be this one from this equation, from 1 by 2 by 1, okay. So tan theta r will get cancelled, tan theta is going to be a2 sin theta upon a1 plus a2 cos phi, right? So tan sin theta is going to be a2 sin phi upon a1 plus a2 cos phi, okay, cos phi, a1 plus a2 cos phi, right? So now for r max, if you have to find r max for this, right, for this equation r max, then cos theta should be 1, right, for getting maximum value of r. So r max is going to be a1 plus a2 when cos phi equal to 1. How? This. So a1 square plus a2 square, it is 1, 2a1 a2, right? So this is going to be a1 plus a2 whole square, root is there, so r equal to a1 plus a2 for cos theta equal to 1, okay. This is, and this is called r max, okay. For r minimum is going to be, or here we can write cos theta equal to 1, that implies cos phi equal to cos 2n pi, right? Value of cos 2n pi is 1, so phi is going to be 2n pi, okay. Phi is going to be 2n pi, and it means these waves are in the same phase, okay. These waves are in the same phase, okay. Next, r minimum is going to be a minus b, a1 minus a2, right, a1 minus a2 when cos phi equal to minus 1. How? Here, if cos phi minus 1, so it is going to be a1 square plus a2 square minus 2 a1 a2, right? It means a1 minus a2 whole square, root is there, so a1 minus a2, that is the r minimum, okay. And from here cos phi is going to be, this we know, right, minus 1 value is 2n plus 1 pi by 2, 2n plus 1 pi by 2, right, or 2n plus 1 pi. So it means they are in opposite n plus 1 pi. Then this value will give, this is going to give value pi. Okay, this one. So it means they are in opposite phase. Okay, opposite phase, they are in opposite phase. Okay, a1 minus a2. Well, so this is about this one. Now this is the a, right? Okay, so now next point is going to be, so now we have this, if, next point, if a1 equal to a2, a1 equal to a2, those amplitude of two waves are equal, right? Then resultant r is going to be root a1 square plus a2 square, means a square plus a square plus 2a1 a2, there is this one 2a1 a2, right? So a square, 2a square cos phi, so this is going to be 2a square cos phi, right? So value of r is going to be, now what we'll do, we'll take common, a square is going to, will take outside, so this is going to be 2 plus 2 cos theta cos phi, right? So value of r is going to be a root 2 plus 2 cos square, will open this value, will put the value of cos phi, right? We know cos 2 theta equal to 2 cos square theta by cos 2 theta equal to cos 2 theta equal to 2 cos square theta minus 1. So here cos phi, so cos square 2 cos square, this is going to be because we know, right? I am writing here cos phi is going to be 2 cos square phi by 2 minus 1, right? This property we know. So this is going to be a root 2 plus 2 into 2 cos square phi by 2 minus 1. Okay, so if we solve it, then r is going to be a cos square phi by 2, right? A cos phi by 2, not cos square, because there is root, right? A cos phi by 2. Okay, so r is a cos phi by 2 if a1 equal to a2. Okay, so in this case r equal to 2 is also here, right? 2 to the 4, 2a cos phi by 2. Okay, so in this case r max is going to be 2a when cos phi by 2 equal to 0, cos phi by 2 equal to 0, and similarly r minimum is going to be 0. Okay, when cos this one cos phi equal to 1. Okay, cos phi equal to 1, and this one, so cos phi by 2 equal to 0. Okay, and so here if r is minimum, if r is 0, it means, it implies y is 0, value of y is 0 if r is 0, right? So that means particle is at rest, okay, this one. So these are the different conditions. Okay, next, intensity we know, right? Intensity intensity is proportional to a square. Intensity is proportional to a square is the amplitude for two waves having equal amplitude. So intensity is proportional to a square, right? So this means I intensity is going to be k. K is any constant, okay? K is constant, k square, right? And then IR. IR is going to be this one, because here we know value of R we know, right? This is A1, this one. So this is the value of R, right? This is the R amplitude, right? So I is proportional to R square means uh, I is going to be a square, a1 square plus a2 square plus 2 a1 a1 a2 cos phi, right? But here a1 and a2 are equal, so IR is going to be k a square value, that is a square is R square, right? Total amplitude. So this is going to be a1 square plus a2 square plus 2 a1 a2 cos phi, okay? Since a square is R square, okay? Both are same, the amplitude, right? So IR is going to be now this is going to be, so a square we know, right? A square we know, so this is going to be I1 square plus I2 square plus 2 I1 I2, because I1 equal to k A1 square, right? And I2 equal to k A2 square, right? So that's why we have put this value, and this is, so this is going to be I1 square plus I2 square plus 2 root I1 I2 cos phi, okay? So this is the one. Now we can write I maximum, okay? I max is going to be root I1 plus root I2 plus root I2 whole square when cos phi equal to 1, okay? If cos phi equal to 1, then I max is going to be root I1 plus I2 whole square, okay? And similarly for I minimum, intensity will be minimum, I minimum is going to be root I1 minus root I2 root I1 minus root I2 whole square, okay? When cos phi equal to -1, okay? If it is -1, then I1 square, this one, this here, have you made any mistake? Yes. So this is root I1, okay? Root I1. Root I1 square plus root I2 square, okay? This one. Well, so these are the condition for maxima and minima, okay? And now next condition, if intensity I1 equal to I2, this is very important formula, right? I max and I min, okay? There would be questions related to it. which were asked in the examinations. Okay, so I1 equal to I2. Let I1 equal to, if I1 equal to I2 equal, I1 and I2 are equal, and that is equal to I0. Then what is going to happen now? Then IR is going to be max IR. Okay, very important point. Okay, so IR is going to be this one, right? Root I1 square I2 square, right? So this is going to be 2 I1 plus 2 I0 cos phi. Okay, if I1 equal to I2, so we'll put value here. Okay, so this is going to give this value. Okay, so IR is going to be very important one, because you'll get questions. 2 I1 I0 we have taken common, 1 plus cos phi, right? And we'll open it. So 2 I0 is going to be 1 plus minus 1, right? So this will get cancelled pi by 2. Okay, by formula 2 cos theta, right? 2 cos theta equal to 2 cos square theta minus 1. So we have used this formula. So this is going to be 4 I0 cos square phi by 2 IR equal to, if amplitude intensity of waves are same. Okay, very important one, this one. IR equal to 4 I0. I will solve questions using this formula. Okay, so IR equal to 4 I0 cos square phi by 2. 4 I0 cos square phi by 2. Okay, very important formula, this one. Now there's some cases, right? So I max for this, when I1 equal to I1 equal to I2, then IR equal to 4 I0 cos square phi by 2. Okay, this is the intensity, total intensity. So, and also I max, maximum value of I is going to be 4 I0. Okay, and the minimum value I minimum is going to be 0. Okay, now the contrast ratio. Okay, very important, contrast ratio. Contrast ratio, contrast ratio, contrast ratio which is R equal to, that is I max upon I minimum. Very important formula. There is a question which is asked in NET, right, from this formula. So this is I max upon I minimum is going to be this one, root I1 plus root I2 upon root I1 minus root I2 whole square. Okay, this is contrast the ratio of I max and I minimum. This question is asked. Okay, so root I1 plus root I2 upon root I1 minus root I2 whole square. Okay, so or you can write, because we know I proportional to A1, right? So this is going to be A1 plus A2 upon, this is amplitude. Okay, A1 minus A2 whole square. This is I, this is R. Okay, I max upon IR. This is I max upon I minimum. Okay, very important formula. You should note down and memorize this formula and solve questions related to this formula. Okay, then this formula is going to be in your fingertips. Okay, so this is the different conditions for waves. Okay, and this is the ratio of I max and I minimum. Okay, now we'll find path difference. Path difference. This is path difference. Path difference. Path difference delta is going to be 2 pi by lambda, or sorry, this is apology, lambda upon 2 pi. Lambda upon 2 pi into phase difference phi. Okay, so this is one. So path difference delta is going to be and we know the path difference is I have also written, that is phi equal to 2n pi, right? So we'll put the value here. So delta is going to be lambda upon 2 pi into 2n pi. 2 pi will get cancelled, so this is going to be lambda upon yeah, this is going to be n lambda. N lambda for maximum value, right? This is called n lambda. So this is called delta equal to n lambda. The path difference equal to n lambda, and this is for constructive interference. Okay, constructive interference for max value. Okay, so this is for constructive interference, that is for bright fringes. Okay, and this is the phi, and phi equal to 2n plus 1 pi. If that is the case, phi equal to 2n plus 1 pi, right? In that case, path difference is going to be, delta is going to be lambda upon 2 pi into 2n plus 1 pi. Okay, and this is going to be 2 pi will get cancelled, so 2n plus 1 pi by 2. 2n plus 1, my apology, pi will get cancelled, so 2n plus 1 lambda by 2. Okay, lambda by 2. So this is for destructive interference. Okay, destructive interference, destructive interference. Okay, so delta is going to be here, delta is going to be 2n plus 1 lambda by 2. That is we can say like delta equal to lambda by 2, 3 lambda by 2, 5 lambda by 2, so on. Okay, and here delta is going to be like we'll write this, so this is going to be lambda, 2 lambda, 3 lambda, so on, right? So this is for constructive, and this is for destructive interference, means dark fringes, and that is for bright fringes. Okay, so these are the ones. So very important for maxima. So we can say for maxima the condition is delta, path difference is n pi. Okay, and for minima or for destructive interference, the path difference is this one, delta equal to 2n plus 1 lambda by 2. Okay, so these are the formulas. Okay, this is about the interference. Okay, now I will solve question first. Okay, question, that is two coherent sources two coherent sources, two coherent sources at S1 and S2, S1 and S2. D is detector, D is detector, D is detector placed at origin, placed at origin, placed at origin, and moves along x-axis, and moves along x-axis, moves along x-axis. Find out number of maxima, number of maxima recorded by the detector, the detector, excluding points x equal to 0 and x equal to infinity. Okay, and lambda is given 6200 6200 angstrom, 6200 angstrom, and lambda, and okay, and D is given 0.34 millimeter. Okay, so two coherent sources at S1 and S2. Okay, D is the detector placed at origin and moves along x-axis. Find out the number of maxima recorded by detector excluding point x0 and x0. Okay, figure is given. I'll make a figure. So this is like this. So there is a detector here, okay, which can move along x-axis, right? And this is the source S1, and this is source S2. Okay, and the distance between this is D, and this complete distance is 2D from origin. Okay, this one, or you can say this distance is also D, and this is D. Okay, to complete distance is 2D. Okay, and this is x-axis, right? So this is detector, these are the sources, right? And this is detector. So now we need to find out the number of maxima. Okay, number of maxima. So solution is, since we know delta for maxima we know, so you need to note down this. For maxima path difference equal to n lambda, and for minima delta equal to 2n plus 1 lambda by 2. Okay, very important, you need to note down it and memorize it. Okay, you will be able to solve questions then. Okay, so for maxima delta equal to n lambda, right? And so we'll find first delta. So delta is path difference between waves from S1 and S2 at origin, right? This is path difference between waves, between waves from S1 and S2 at origin, right? So part difference between waves, this is the sources, this is the sources, okay? Part difference between waves from S1 and S2 at origin from here, right? So delta is going to be so value of delta, this implies value of delta is going to be this this complete distance is 2d dt, right? 2d. So the part difference, this distance, this is the part difference, right? This source is here, this source is here. Part difference is 2d minus d, 2d minus d. So the part difference is this one from origin, right? This is here and this is here. So this distance d, that is d. Part difference is d, right? So now we'll write the formula. So d in place of part difference, that is d. So d is going to be equal to n lambda. So from here n is going to be d by lambda, okay? So we'll write it. So value of d is 0.34 mm upon value of lambda is 6200 angstrom, right? We'll solve it now. So this is going to be 0.34 into 10 to the power minus 3 meter, and this is going to be 6200 into 10 to the power minus 10 meter. We'll convert it into meter, and this value is going to give, that is 5408.38. This is the answer. This is the that is number of maxima, okay? So this is the answer for number of maxima, okay? So very simple. So part difference we have found from here, right? What is the part difference? This starts from here, this starts from here, yeah? The part, this distance is 2d, so 2d minus d, so this is going to be d, right? This is the part difference, okay? So this is the question. Now we are going to study Young double slit experiment. Very important, guys. You get a question in your NET exam, okay, and other exams as well. Very important. So Young double slit experiment, okay. Young double slit, Young double slit experiment. Young double slit experiment, okay. That is YDSE, okay. In short, we say YDSE, okay, Young double slit experiment, okay. So, so you know the Young double slit experiment means this one, right? There are two slits, right? From here you'll get the wave, spherical wave, right? This is the source, okay, and this is the screen, and this is the distance between screen and slit, right? And this is S1 slit, this is S2, and at any point P they make a